Hello YouTube, my name is Matt and I have a strange addiction to purchasing cheap Chinese electronics. Anyway, hi, I'm going to show you some of the cool things that I purchased recently and all the things that I'm into at the moment. In fact, I'm going to give you a general tour of my home lab with all of the kind of weird and wonderful things that I have in it. So let's switch the camera around and hopefully make this a little less bobbly. So the main thing I wanted to talk about is this new board which I've got, which is by no means cheap Chinese electronics. In fact, it's reasonably well-priced Bulgarian electronics from a company called Olimex Limited, which, from what I can tell, they've been making development boards for about 20 years or more, and they've got their own design and manufacturing plant. And this is a really interesting looking board. It's called the ESP32-PoE. You can guess what it is and what it does. Now, most people buy espressif ESP boards, such as the ESP82-66 or the ESP01 or the ESP32. Most people buy those for the main reason of the fact that they have wireless built in. And, you know, it might seem a bit weird that you might want to actually put a network interface, an Ethernet interface on this, because the whole point is that they're great little development boards for kind of ad hoc installations around the home for with wireless, because in fact this one does have obviously the PCB wireless antenna, and it does work wirelessly as well. They call it wireless as a backup, I think. Now there's two different ESP32 boards with with Ethernet and PoE that you can find in the world, and this is one of them. The other is called the WESP32, the WESP32, which is quite a lot more expensive. And the main difference that people talk about is that this one has got no galvanic isolation between the USB port and the power over Ethernet. Now, for me, that doesn't really matter at all, because I've built my own Arduino and W5100 boards. This is not, I didn't build this board, but I've put them together, and I've used my own kind of spliced DIY power over Ethernet cable with a little power supply. In fact, why don't I show you? This can be a little show and tell for what's in my lab. Bring some light over here as well. So let's have a quick look for those. Yeah, so here's an example. Actually, I don't think this has got the W5100 in there, has it? No, it hasn't. It has a little control board that I built. This is a base board for an Arduino Nano, which would go along here. I did this last week actually with an iron and some toner transfer from a laser printer. And then I put my little W5100 board in there, and they go in these things here. I've drilled it all out. So the way that this would work is to get one of these, I'll pop him on there. That's a little cutout. That would go in that way. This is a double-sided board, so those are the connections for the 5100. That would go there. Get an Arduino, and that would go kind of butted up against it like that. In fact, I use header pins so that I can change the Arduino if necessary or take it out. And then my form of galvanic separation between the my DIY PoE and the USB is by way of a very high-tech way of doing it. That's by putting one of these on there. So that's one way of doing it, isn't it? But you just have to remember to obviously switch the toggle on and off when you're doing it. But for me, having no galvanic isolation between PoE, Ethernet and USB is not a big deal, because once you've programmed this and then you can put it in your ceiling void or whatever you want to do, you don't really need to plug the USB in again. And if you do, you just need to know to unplug the Ethernet cable. It's not, for me, a big problem. Perhaps it means it's not standards compliant, I don't know. Anyway, it strikes me that it's a really good idea to try to wire your home up using Ethernet rather than putting wireless devices around the place. One of the main reasons that I like the PoE board is because you couldn't really realistically put your multi-sensor that is ESP based in the ceiling and wire a 5-volt power supply to it, because how are you going to get your 5 volts to it? The power block will need to be a wall wart, presumably, and it will need to be in a maintainable position. You don't want to actually put that in the ceiling, because when it goes, you're going to need to replace it, or you're going to need to see what's going on. So, of course, if you put that up in the ceiling, you need to bring your 5-volt wire down and plug it in your plug. And, of course, by that time that it's up in the ceiling, you've lost power, and it's not really going to work, is it? And it's just a naff solution. So this is why PoE for multi-sensors that are actually installed into the home seems to me like a really good idea. And this is the cheapest PoE development board I've ever found at £17.95. It's very, very cheap. Now, whether I can get it working or not is a different matter. I have been able to get it working once, and since then I've not done anything except connected a couple of things to the input pins. Since then it has not worked over the Ethernet connection. It does get power over Ethernet, but I've turned off PoE. In fact, I'm able to turn that off by logging into the switch. Excuse me. Let's just pop the login details into there. And we're logged in. And I'm able to head into port management and switch off PoE. As you can see, this is enabled at the moment, but if I hit edit and turn off PoE, then that means I can plug them both in at the same time. Now, in actual fact, I have this one going into a non-PoE switch, so it's not actually that switch anyway. But I'll just show you what happens. Let me plug this in, and now I've pulled up the, there we go. Now, in order to test with this development board, you do need the USB plugged in so that you can see the serial interface, so that you can see it reporting things. And so if I just pull up this sketch, now this is the Olimex ESP32-PoE Ethernet Arduino, which is the same as the ESP Ethernet Arduino, except they add these two lines here: define F-clock mode, F-clock GPIO 17 out, and define F-Phi power 12. So technically, according to Olimex, this sketch was downloaded from their GitHub, and I've done nothing to it, and that's what it does. So if we go to tools, and obviously I've installed the board, which is available under the ESP32 Boards Manager, and set these settings, set the COM port, and then I can upload. So let's just upload like that. Compiling sketch. So it's writing the flash. Now, for some reason, this doesn't scroll automatically. So for impatient people like me, I have to sit here doing this. And now it's flashing. And it's a little slower than an Arduino, isn't it? But we're almost done. There we go. It says done uploading, hard resetting via RTS pin. So if I now pull up the serial monitor, I'm going to show you what it did do on one occasion and what it no longer does, which is slightly frustrating because I haven't been able to get this to work with the Ethernet interface. So, serial monitor. if I hit the reset button on here manually after 3, 1, 2, 3, this is what we see. It says F started, and then it says F connected. Now what should happen in this sketch is it should then get an IP address and tell you what the IP address is over the serial monitor. But it doesn't do that. And the other thing that it should do is as soon as you pull this cable out, it should say F disconnected. So I'm going to do that now. And it doesn't say F disconnected. So let's clear the output and then let's reset the device after 3, 1, 2, 3. Now we've got F started. Now previously that said F connected when it wasn't physically connected, and it's not doing that now, so perhaps it's going to work. This is what it did when it worked. So now if I can plug this little board in and take you back there, F connected, that's what it did before. So it has sensed that it is connected. Now it's not appearing to get an IP address, is it? Because it, as I say, should show on the serial interface, on the serial monitor. Put that over here so we can move more quickly. What happens if I disconnect it? Now I've physically disconnected the cable and it doesn't say disconnected now. So there is some kind of unreliability with this. This is what I'm finding. And I don't know what that unreliability is down to. Let me reset it again. Why don't I bring this here? I'll be careful where I touch, although the PoE is not plugged in, so we shouldn't electrocute ourselves. So here we go, reset. That's nice and quick. F started. That's a good sign as well. So now I'm going to, sorry about the dodgy filming now. I'm going to plug him in now, ready, steady. And now it doesn't say F connected. Now I have tested my cable, because obviously you can see this is a, I made this patch cable myself. It doesn't say connected now. Reset, F started, lights come on. Now it says F connected. Reset, F started. Now it says F connected. Reset, F started. Now it does not say F connected. So you can see why I'm having issues, and it's a shame. I think having messed around a lot with Arduino Nano and these W5100 breakout boards, they're called the Funduino board. There's a couple of little technical bugs with this, hardware bugs with it, where you have to, there are some options to overcome them, but it's basically to do with the reset line not working properly. But you can overcome them by actually just tying reset high, and then I think resetting the Nano a couple of seconds after this gets power. Right, now that suddenly says F connected, so what's going on there? Let's leave that, shall we, and see what happens. Anyway, I'll give you a little tour of the rest of the setup here, or the home lab. And this is my sensor box, in which I have these AM, what are they called? They're not called the AM2, I don't remember the name of these. But they're very common, and I picked these up for a couple of quid many years ago. Now, after watching one of our fellow automation YouTube channels, Ben said, this is on Brewer Automation, Ben said that he had huge problems with interference with these, and I've seen a couple of other people posting online about having problems with interference. Now, I haven't tested these extensively, but they work perfectly when I did test them. But as for, you know, using them to, you know, for days on end, turning the lights on, etc., I haven't done that kind of testing. But what they recommend is getting one of these, which is an AM. Let me pull up. I can't remember the model, but I have stored it in one of my sketches, which is in fact my Olimex sketch. This one here, I've called it PoE. It's clearly not PoE, it's clearly sensors and stuff. Yeah, the AM312-PIR. So apparently these are much more reliable. Certainly I've got it downstairs in our building site, acting as an intruder alarm in multiple places, connected to some ESP32-66s, and sure enough they work really reliably. I like buying switches. These are Rotary Encoders. If you don't know what they are, Google them, because they're quite fascinating little devices, the way that they work. And they click, and I use an Arduino library for this called the Click Encoder, which is a good library. And I bought some of these little touch, I think these are Adafruit based touch ICs, basically, just to have an experiment. And, capacitors, etc. Oh, now this is an alcohol sensor. So if you get drunk, you can see how drunk you are. So that's quite fun. I've had a go on that. Now these people ask me about in YouTube, in comments and past YouTube videos. They say, where do you get these wonderful switches from? And they're wonderful because they've got LEDs in them and they look really cool. I think they look really cool. And the answer is I don't remember where I got them from, but I have answered them online. And if you're interested, then I'll put the links for these below. DHT22s, obviously we know what these are, or the AM2301s, depending on what you want to call them. Oh, it's 2302s rather. Temperature and humidity sensors, which are accurate to the nearest 0.1 of a degree. They're quite slow to query. You can only query them every 2 seconds or so. They're quite good there. And these are just a whole bunch of RF, I believe they're RF receivers and transmitters. So tray number 1. And then we've got some ultrasonics distance sensors in here. I'm sure you've seen these. DHT11s, they're the slower and less accurate, perhaps not slower, they're the less accurate temperature humidity sensors. I went wild on a spree of multicoloured or tricoloured LEDs. They're quite fun. I've got one of those working in my alarm system. Lots of little OLED displays, which are great. I've never used these buttons with the... I was going to try to put these in a kind of a metal faceplate, so I thought they'd look cool, but it's actually really hard getting it so they don't all fall out when you take the faceplate apart, and then it was just a bit of a nightmare. Here, more of those. What is this? Ooh, this is fun. This is called a Rotary Encoder LED ring, and just for testing purposes, this is a Rotary encoder. It's kind of a horizontally mounted one. It's a click encoder as well, and a little LED ring. It is what it says on the tin. This button I've had in my electronics toolbox since I was 15 when I studied electronics GCSE at school, and that is nostalgic. Then we have some of these. These are the TEMT. What are they called? There we go. These are called the TEMT 6000s, and these are photo transistors, I believe. They send out a kind of a lux signal. Well, it's not. They're not. I don't believe they're digital lux sensors, but they are light sensors of some sort, and it sends out. The voltage varies on the S pin. The more light there is, so that's quite good. Obviously, you want to get some of these, and then you want to get some LDRs, which are very, very cheap, which I've got in another box. and compare the results, because that's quite fun. This I have never actually used, never even tried to use. It is a NFC module, and my big idea for this wasn't that big, but my idea for this was in my wall controllers. What I wanted to do was to have one of these in each one, so that you could do things to interact with RFID cards, such as I could keep, because it's not very practical choosing the music that you want to play from my wall controllers, because they're quite basic light switchy style things with dimmer knobs and buttons and displays, but they're not touch screens or anything like that. So the idea was that I was going to keep some, get some RFID beer mats, and we'd have them around the house with different things on. You could perhaps put some in a little, like a coaster holder on the wall next to the thing, each with a kind of a Sharpie written album name on it. And I was going to, pass them out to friends. They can choose the music they want to listen to and then tap in, kind of like a jukebox. That was my idea for that. In here we also have some of these BMP 180s. I think people recommend using the newer versions of these chips. That says GY68, that's not BMP 180. This I think is, oh yeah, it is. That's the BMP 180. This is a barometric pressure sensor, if you don't know. That's going to go in the multi-sensor when I finish building it. And these are, I don't really know where I got these. They are kind of water sensory things. I don't know. Haven't used them, haven't ever even installed them. Oh, and these have been invaluable. I highly recommend PCB. I mean, again, these are cheap Chinese stuff. PCB connector blocks, great for connecting peripherals to your homemade PCBs. These are, how is this the NRF11? Is that what this is? Someone on YouTube, tell me. I don't ever think I got these working, but I believe they're transceivers. I might be wrong. They're certainly something with an antenna. Now under a boring DuPont, I got into making my own DuPont connectors at one point and then realised that that was a very laborious task, and don't recommend you do it. So that's box number one. I've pared down the boxes. I used to have boxes up to here, really. Oh, this is my microprocessor. Nope, my development board box. So the breadboards. Now, anyone who knows me knows that I absolutely love the Arduino Nano because it's small and it's got USB programming on board. And I love the Arduino Mega. That's not one. I've got plenty of those under here. Lots and lots of Megas. And the reason I love the Mega is... Here's one. The reason I love the Mega is because it's just got loads of pins, but it's quite big, and the thing that frustrates me is why do we have to have this enormous USB connector on it? Again, they're great for development, but really what you want is something that you can actually install into the home. So I've been toying with the idea of making my own kind of custom boards with this Mega chip on it. Mega 2560. Incidentally, this is my wall controller project that you've probably seen before, and what I like to do is to use this Fundrino red board, because they're now down to about £3.50 for this network board, and the Megas are kind of £6, so you've got yourself an absolute truckload of I/O with network connectivity for £9. You need to add to it some way of getting power to it, so I've been using these black buck converters, which are in my, I would like to say this is my discrete components box, but clearly it's not. Yeah, I've got loads of these. I took one apart actually to see what was in it. It was just a board inside there. But these claim, and I'm not sure I believe them, they claim 2 amps, and I believe you're able to put in something like 30 something volts. I can't remember, but I've certainly kept well within the limits there. I don't know why it says DC 12/5, because these are definitely 5-volt buck converters. And they say full re. I don't know what that refers to. I found them very, very cheap online, and they've been powering my wall controller for a number of years now, and it only broke once in there. And I, of course, had that connected to these little terminal block connectors, and so I was able to replace it very quickly. I've managed to blow these up lots, but only because of my own stupidity. And then, I've got a little tray of buck converters, teeny tiny buck converters. Again, I can't tell you exactly, certainly as mini, I can't tell you exactly what these are, but they look adjustable, so that's nice. So that's my buck converters. MPR121, MPR121, which I think this is the MPR121, which is a 12-channel touch sensor chip breakout board, and then some hex level convert. That's on the MPR121 without the pins. Now these are pretty good. They're hex level converters. So if you've got multiple signals which need converting up from 3 to 5, or down from 5 to 3, I can't remember which way, then this is your one. This is what you need. Hex. Here's one I prepared earlier. Couple of things, and then more my kind of Julian Eyelet style obsession with buck converters. I really like these ones. I use them really everywhere, actually, in development. Some SMD components, resistors, etc. Some knobs. Who doesn't like knobs? This was from when I was thinking of trying to make my own W5100 board, and I gave up pretty quickly. The ENC J2860, or the ENC 2860J. This is a, you can connect this to your Arduino and communicate with the network, but I don't recommend it because it's a bit of an idiot. The ENC 28J60. It's much smaller than my red Fundrino boards. These things here, much smaller, so more enticing. However, it doesn't have, it doesn't support TCP offloading. It basically just doesn't support anything. You've got to support it all in software, and then it makes your sketches for your Arduinos absolutely huge, because you need a different library, and it's slow and unreliable and crashes. So yeah, don't recommend that. But perhaps other people have had better luck than I have. There's some random fuses. Anyway, this is getting a little boring, so let's move on to the next. Where were we? We were in my development board box. Oh yeah, so recently, but only recently have I got into these ESP boards. And I bought quite a few. Node MCUs, ESP32s. This is an ESP32-66. To be honest, I don't really know what stuff is until I Google it, look it up, connect it up, and get it working. But the thing that I found about these is that it's very, very quick to get them working. And you can flash them with Tasmota or some other software that someone else has written. ESP01s. These are great if you don't need to do anything with them. Fluffy. That's an ESP01 mated with a special ESP01 DHT11 subboard, and I've never even used it. I thought it was fun to buy that. But ESP01s are great if you want, one pin to control something. Lots of things that you would want to put around the house would have only one pin. This is my kind of weird USB to TTL thing. Don't know why I did that really. What else do we have in here? Oh yeah, and I've got some of these as well. I've installed a couple of these. Is it the WeMOS? I've lost it. I've lost my WeMOS. Here it is. Is it WeMOS? Is this the WeMOS D1 Mini? Is that what that is? I don't even know, but I certainly know it looks nice, and I've used one, and I've installed one downstairs. I can't remember. A little reset button. They're teeny tiny boards, and they're so good for just whacking in places and using as an alarm sounder or as a PIR for temporary stuff. But as I say, in the final home, I would rather be going with wired. And I still don't know how we're going to do that. That's a little panel mount volt ammeter. And in here, I experimented with, oops, I like my Arduino Nanos. However, I thought perhaps I should just get into these. They're even smaller because they haven't got USB to TTL on board, which means you need to program them with a TTL programmer, such as this thing here. But yeah, they're really small, and look how many pins. There's loads of pins. There's so much I/O in such a small space, which is why I bought these. These should probably be the basis of some permanently installed stuff. I think they're pretty good for that. And then I've got my wire box, my hookup wires, my stranded and my solid. Ooh, DuPont. I've got some 20x4 LED, backlit LED character displays. I've got some 16x2s, and then somewhere, not here, I've got a load of graphic OLEDs as well, because I'm very fond of graphic OLEDs. I've got two different types of these. They are differentiated by the driver that is on board. Anyway, I think I've rabbited on for long enough. But I hope you have enjoyed this video, and if anyone can shed any light on how to make this beauty work, I'd be really interested to hear about it, because I've clearly been, I've breathed success with it, but I've not completed in a successful way. Anyway, thanks for watching.